The logging service is the first service we are going to drill down into. Now, this may sound a little bit strange. After all, it is the most boring service. Let's start with something more interesting. Well, the reason we are starting with this service is twofold. First, we want to emphasize that logging is important. Many developers and sadly architects treat logging as an afterthought, but this is the wrong way to handle it. Logging is one of the cornerstones of every application and therefore should be treated as any other service. Second, we want to build all our services in a way that already includes logging and not adding it later. For that, we will need the logging service ready so the services can communicate with it. True, in our specific application, the logging service reads from a queue and is not interacting directly with the other services, but still, it's always a good idea to begin with it. So, let's go. Here are the steps we need to take for the components drill down. First, decide on the kind of application. Is it web app, service, desktop? Second, decide on the technology stack of the component. And third, design the architecture. Okay, so let's begin with the application type. And for that, we need to remind ourselves what the logging service is supposed to do. It should read log records from a queue, perhaps perform some kind of validation, and then store them in the data store. And here is the important thing. The logging service does not wait for any request. It is always on and once in a while pulls data from the queue. So let's see how this stacks up against the application types we know. So first, web apps and web API. They are both off the table since, as we just said, the logging service is not based on a request-response model, but is always online and initiating its own activities. It's definitely not mobile application. It runs on the server and not on the client. What about console? Well, it looks like a good fit. Console applications are best suited for long-running processes while offering limited user interface. This is exactly what we need from our logging service. We don't need any UI and it is a long-running process. So this is a great candidate. Next is the service. Remember that services are quite similar to console with two important distinctions. They offer no UI at all and are managed by some kind of service manager. So it looks like the logging service can also be a service. Last is desktop application, which of course is not relevant for the logging service since it runs on the server. So we are left with console app and service. Which one is better? Well, actually, there is no definite answer, and it depends mainly on personal taste. I would prefer to make it a service, but if you design it as a console application, you won't make a mistake. Okay, so we have the application type. Next, the technology stack. As you probably remember, when deciding on the tech stack, we first need to define what are the elements in the component that need their stack to be selected. In our service, there are two such elements, the component's code and the data store. Let's begin with the code. Since the logging service is going to be a service, we don't have a lot of requirements from the technology stack. We need the code to be able to access the Queue API and store data in a data store. This is nothing special and any development platform can do that. In addition, there are no special requirements about the performance. Of course, we want it to be fast, but there is no specific requirement that limits us here. So now it's time to go to the developers and ask them what platforms they have experience with. Let's do it. Well, it looks like the development team is familiar with the Microsoft stack, meaning .NET Platform and SQL Server. That's good, since .NET is a general-purpose platform that can be used in services as well as web apps, and that might be useful when we will discuss the other services. The only caveat here is that .NET is a little bit outdated, and new project should use .NET Core, which is the new cross-platform modular successor of .NET. The team is not familiar with .NET Core, but after a short discussion, we agree on an onboarding process and decide together the service will be based on .NET Core and the database will be SQL Server. Now, it should be noted, if the team is familiar with, say, Java and MySQL, that's great too. Python and Postgres, also good. Almost any combination will work here as long as the platform supports console app or service and can access database. Okay, great. So we have the technology stack. Now let's design the architecture. Remember our discussion about layered architecture, how we said that in most cases this is the go-to architecture of every component? Good. Let's see if it fits here. As you probably remember, layered architecture has these three layers: user interface or service interface, business logic, and data access that writes to the data store. Now, do you think this pattern fits in this case? Take a few moments to think about it. You can pause the lecture and resume when you reach a conclusion. Okay, so I hope you have an opinion about whether or not the layered architecture is a good fit for the logging service. And here is what I think about it. It fits, but not quite. The main issue here is the first layer, the UI or API layer. The logging service has no UI or API. It's a long-running process and exposes nothing, no API and no user interface. The rest of the layers are actually quite relevant. We need the business layer to handle the log records, and we need the data access layer to access the database. So, what we are going to do is tweak the classic layered pattern and modify the top layer to be a polling layer. This layer is responsible for accessing the queue and retrieving the log records to be handled by the business layer. And this is how the updated layers pattern will look like in our case. So, how will the component work? What is the flow it implements? Here it is. The polling layer runs a timer which polls the queue every few seconds. If new records are returned from the queue, the polling layer sends them to the business logic layer. This layer validates them and makes sure no garbage has been sent. If everything is okay, it sends them to the data access layer, which saves them to the database. And that basically is the inner architecture of the logging service. There is another thing I would like to point out. Remember our discussion around dependency injection, how it eliminates dependencies between code components? Good, we are going to use it in the logging service to avoid coupling between the polling layer and the business logic layer, and between the business logic layer and the data access layer. Lucky for us, .NET Core has a great dependency injection mechanism built in, using the Microsoft Extensions Dependency Injection package, and it will do all the heavy lifting for us. Actually, when the dependency injection is so built in, I really have to struggle hard to find reasons why not to use it. And last thing, while the code that handles the polling from the queue and the validation is a vanilla code that uses no external libraries, the data access layer will utilize Entity Framework to access the database and save the records. This library gives us ORM capabilities, which basically represents database records as full-blown objects. Okay, great. We just designed our first service. We now have an architecture for the logging service, complete with its type and technology stack. I hope you enjoyed this experience and feel ready to continue to the next service. It's going to be at least as fun as this one. Remember, if you have any questions or comments, do not hesitate to contact me, and I promise I'll get back to you as quickly as possible. So let's continue to our next service.